Hello to all of you and welcome back to my SP2 channel. This video is all about the concentrations of solutions. We're going to be looking at molarity specifically. I have interconverting, molarity, moles, and volume. I have a little bit on dilution, and we also have a practice for you at the end. Okay, so we're going to start by kind of introduction to concentration, and then we can look at the molarity after that. So concentration is an important concept in biology and biological system as it influencing many of the process like nutrient transport, enzyme activity, or even cellular functions. For example, if the concentration of iron in our blood is lower than the optimal value, this condition is called iron deficiency. In such cases, the iron supplement may be required to restore the normal levels of iron. And ironically, I am one of those iron deficient people on this planet, which is not fun, right? Now, the concentration is a measure of how much solute is dissolved in a given quantity of either solvent or solution, right? And it allows us to describe the relative amounts of substances in a solution, which is essential for understanding and predicting our chemical reactions. Okay. Now, in chemistry, there are different ways that we can express concentration. One of the really common one is known as molarity, that goes by capital M, and it's going to be always the number of moles of our solute divided by liters of solution. So we have to be careful here. On the top, it must be moles of solute, and what I have in my denominator must be the liters of solution. So even if I have, let's say, milliliter, right, I'm not allowed to use the milliliter. I have to convert that to liter because that's how the molarity defines, right? Okay. Looking at this example, it says calculate the molarity of a solution made by dissolving 23.4 grams of sodium sulfate. We also have the chemical formula in enough water to form 125 milliliter of our solution. Okay, so anytime that I have grams, I need to convert that to the moles, right, using the molar mass. You can look at your periodic table and you can calculate the molar mass of sodium sulfate, which is going to be 142.1 grams per mole. So starting by your mass, 23.4 grams, and you would have your molar mass here because you have to have, consistency for your units. You can cancel out these two. And what I have on the top is moles of my sodium sulfate, which is exactly what I have as my final answer for this step. Okay, so I've got my moles. Now the next step is the volume that is given to me is actually milliliter. So I need to convert that to liter. So I know that 125 milliliter goes here, and I can say thousands milliliter is going to give me 1 liter. And again, you can cancel out the units. Your final answer for this step is 0.125 liter. Okay, so you've got the moles, you've got the liters, and all I need to do here is I need to divide them to get the concentration in molarity, right? Which is going to be 1.32 mole per liter. You can also write as a capital M, which is exactly what I have for molarity. Okay, now we're going to be looking at how we can interconvert molarity, mole, and volume. Okay, so here's the idea. If I know any of the two of the three quantities in the definition of molarity, I can calculate the third one, right? So for example, if I have the molarity of nitric acid, it says we have 0.2 mole per liter. This means that I have 0.2 moles of nitric acid per 1 liter of solution, right? So I can calculate the number of moles of nitric acid in any given volume. Let's say I have 2 liters, okay? I'm going to set up my calculation here as I have 2 liters, right? And I know based on the molarity definition, 1 liter is going to give me 0.2. Make sure that you are canceling out your units, right? And what I have at the end is going to be moles of nitric acid, right? That is pretty straightforward, right? Okay, now we're going to be looking at dilution. Okay, so when you're thinking of purchasing a chemical in our labs, right, typically the solution come in a very high concentrated form. You can call those stock solutions. Okay, now in order to prepare the solution at lower concentration, which is what we typically need, we need to add the solvent, which is water, in order to dilute, right, dilute the stock solution. This process is called dilution. Okay. Now, the main point here is we have to be always remember when you're adding solvent to your solution, the number of moles of solute is not going to change, right? So the moles that I have before I add my solvent and the moles that I have after I add my solvent to dilute my solution are going to be equal to each other, right? And that totally makes sense. You're adding your solvent, so you're not touching your solute, right? Now, a kind of quick reminder, if you try to dilute, let's say, an acid in the lab, we always need to add the acid or the base to water first. And then you can add a little bit more water if you want to top it up to get to the exact value, right? And the reason for that is adding water directly to the concentrated acid or base is going to cause like a splashing, which is not going to be safe, right? So this is just the kind of point, just in case that you want to try this in the lab. Okay, so in the lab, for the purpose of calculations, right, like this one, we often can use the equation based on the principle that the number of moles of solute remains the same in both concentrated and dilute solutions, right? Now, since the moles is going to be molarity times by liters, right? I can kind of rearrange my equation and I can write it as the moles of the concentrated solution by the volume of that on the left side must be equal to the moles of your dilute solution, right? Times by the volume of that. Okay. Now keep that in mind for the volume, right? It can be any units. It doesn't have to be liter. It can be milliliter, it can be microliter, right? As long as they are consistent, we're going to be fine. But if you look at your M, right, your capital M, which is your molarity, the concentration, that must be always mole per liter. Okay, cool, cool. Okay, that brings us to our first practice. So here's the question. How many grams of sodium sulfate are required to make 0.350 liter of 0.500 mole per liter of sodium sulfate? So if you look at the definition of molarity, we're going to have moles per liter. And I'm going to do a little bit rearrangement. I'm going to solve that for the moles, which is going to be the liters times by the concentration of sodium sulfate. Plug in the values. You've got your liter given as 0.350. And we also know that if I have 1 liter, it's going to give me 0.5 moles of sodium sulfate, right? Double check your units. You can cancel out the liters of the solution, and that is going to give us the moles of sodium sulfate. Okay, now the next step is converting the moles to the grams, right? Which is going to be based on your molar mass, right? So starting by moles given here, and 1 mole is going to be 142.1 grams of sodium sulfate. And again, you can check your units. They have to be consistent. You can cross them out. So your final answer is going to be 24.9 grams of sodium sulfate. Okay, so looking at the second practice, the question here is how many milliliters of 3 mole per liter sulfuric acid are needed to make 450 milliliter of 0.1 mole per liter of sulfuric acid. So there are going to be two different ways that I can, solve this problem. Let's say method one. I'm going to start by calculating the moles of sulfuric acid in my dilute solution, right? Using the volume that is given by the question stem, right? And I also have the concentration, which is 0.1 mole per liter. So that will be 1 liter, which is giving me this many moles of sulfuric acid. Looking at the units, they are consistent. You can cancel them out, and that would give me the number of moles of sulfuric acid. Now, I know that this many moles must be in my sulfuric acid solution before adding the solvent, right? So for both of these, dilute and concentrated solution, we're going to get the same number of moles, right? So let's calculate the liters of the concentrated solution. I know that I have the same number of moles, right? And now the concentration is 3. So I'm going to have 3 moles of sulfuric acid giving me 1 liter of solution. And again, you can cancel out these units. And our answer is 0.015 liter, which is exactly the same as 15 milliliter, right? So that will be our final answer. Okay. Now there's another way that I can arrive to the exact same answer, and that is using the equation, right? Which is probably easier, kind of shorter, right? You just need to plug in all the values. The left side is what I have for the concentrated sulfuric acid, and the right side is all I have for the dilute solution. You can solve it for your volume, and that is going to give us 15 milliliter. Okay, cool, cool. Okay, thank you very much for watching this video. If you found this video helpful, please don't forget to give it a thumbs up. You can share that with your friends. If you're enjoying the content and you want to keep learning with me, all you need to do is you need to subscribe, right? You're going to get a notification anytime that we have a new lecture posted for you, right? I would love to hear from you guys. You can always drop a comment below, or you can email me if you have any questions or concern. I would love to continue making these videos for you. You can support me, and it means the whole world to me. Thank you very much. I'll see you in the next one. Take care of yourself, and bye bye for now.